Okay. And now, I plan, we may have the food testing, food evaluation about the week 17 and week 16 and week 17. For example, we can test the different drink, different foods, and you can evaluate, or you can find, for example, I may give you 3 cups of drink. 2 are identical. 1 is different from the other 2. And can you find which one is the different one? Actually, it's very common in our food science field to test whether the person is very sensitive to certain food or flavor. It's very common use. And I may test, but when I was a graduate student, we always been asked to join the kind of activity. We test wine, beer, and some sweet drink, coffee, something like this. And I plan to have this one. And sure, this classroom, we cannot eat or drink. In the future, I may move to different classroom, maybe in the B building. I will let you know in advance, because I need to prepare something in advance. Is that okay? Okay, let's move to chapter number 8. Okay, chapter number 8. Estimation. In hypothesis test, the purpose is to make a decision about the perimeter in terms of being greater than, less than, or not equal to a value. But if you want to actually know what the perimeter is, you need to do estimation. And there are 2 types of estimation: point estimation and confidence interval. Okay, let's check the chapter 8.1, basic concept of confidence interval. Then chapter 8.2, one sample interval. Okay, let's move here. Okay, a point estimator is just the statistic that you have calculated previously. As an example, when you want to estimate a population mean, mu, the point estimator is a sample mean, x bar, to estimate the population proportion, p. You use the sample proportion, p height. In general, if you want to estimate any population perimeter, we call it theta. You can use the sample statistic theta height. Point estimators are really easy to find, but they have some drawbacks. Not perfect. First, you have a large sample size, then the estimate is better. Okay, not better. The larger the sample size, it will be better. But with a sample estimator, you don't know what the sample size is. Also, you don't know how accurate the estimate is. Both of these problems are solved with a confidence interval. Let me say that 3rd time. Confidence interval. Okay, what's the definition of confidence interval? This is where you have an interval surrounding your perimeter, and the interval has a chance of being a true statement. In general, a confidence interval looks like theta height plus minus e, where theta height is the point estimator and e is the margin of error term that is added and subtracted for the point estimator. Thus, make an interval. For example, it's impossible to get the population, and thus we need to estimate the reasonable range. We call it confidence interval. Generally, it's plus minus a value plus minus the other value. Okay. interpreting a confidence interval. Like this one, the statistical interpretation is that the confidence interval has a probability 1 minus alpha, where alpha is the complement of the confidence interval. As an example, if you have 95% confidence interval that the probability of the P is greater than 0.65 but smaller than 0.73. Again, let me say that again. You have 95 confidence that the range should between those one. Then you will say there is a 95 chance that interval from 0.65 to 0.73 contains the true population proportion. Let me say that again. It's very hard, it's impossible. It needs money, time, and labor to get the population proportion. With limited labor, with limited time, with limited money, we use the samples to estimate. But after our calculation, we believe from the estimation, this range, 95% of the true population proportion is in this range. But you may ask, how about the other 5%? Sure, if you enlarge the range, then you can get the 99% of the interval, but it makes no sense because we want to know the specific range of the population proportion. When you enlarge it, it makes no sense. But when you narrow down it, sure, the probability is lower. Okay? And 5% will not. The wrong interpretation, that is, there is a 95% chance that the value of P will fall between this range. The reason that this interpretation is wrong is that the true value is fixed out there somewhere, and you are trying to capture it within the interval. Okay, let's check here. Example 8.1.1, stating the statistical and real-world interpretation for confidence interval. Suppose you have 95% confidence interval for the mean age of a woman get married in the year of 2013. The range is 26 and between 26 years old and 28 years old. State the statistical of the real-world interpretation of this statement. Okay, let's check it here. A. There are 95% chance that the interval between 26 and 28 contains the mean age a woman gets married in the year of 2013. Okay, you need to learn how to describe this one. The second question, suppose a 99% confidence interval for proportion of Americans who have tried marijuana. Sure, it's illegal in Taiwan. So far, it's either marijuana, that is illegal in Taiwan. Okay, but I heard about that is okay in Netherlands. But maybe we can move to European to learn something like this. Okay, the proportion is, the range is between 0.35 and 0.41. Set a statistical and real-world interpretation of this statement. There are 95 chances that the range of the interval between 0.35 and 0.41 contains the proportion of Americans who have tried marijuana as the year of 2013. The real-world interpretation, the proportion of this one, the proportion is between 0.35 and 0.41. Is it okay? Because it's very hard, it's impossible to get the population value. Thus, we use the sampling method to estimate the population range, but it's impossible to get the exact value. Thus, we set 95% of the confidence interval. Sure, you can check 99%, 95, 90, 80 is up to you, but regularly we use 95%. Okay, let's move. And see here, about the figure 8.1.1, effect of confidence interval on width. The higher the percentage, the wider the range. See, 95% in the purple line, 95% in the blue line, and 90% for the red line. Sure, if I elongate the purple line, you can get close to 100%, but it makes no sense. It's impossible for you to prepare all numbers here. Thus, generally, the shorter line, the better. But you may lose the confidence in the real number here. Okay, let's move. And the figure 3 affect the sample size on width. And now look at the sample size affect the size of interval. Suppose figure 8.1.2 represents confidence interval calculated on a 95 interval. The same 1, 2, 3 are the same in a 95 confidence interval. A larger sample size, for example, n equals 1000, n that is 100, or n that is 30. Representative sample makes the width of the interval narrower. This makes sense. Larger samples are closer to the real population value. The point estimate is pretty close to the true value. Okay, we have a concept here. If we have chance to get more and more samples and calculate the value, for example, the mean, and we are confident the confidence interval is narrower. But if we use limited time, limited labor, and limited money, we get only 30, and the confidence interval is larger. Okay. Homework here. Suppose you compute a confidence interval with a sample size 25. What will happen to the confidence interval if the sample size increase to 50? Obviously, when we use larger sample size, the range, the confidence interval will become narrower. Okay, let's move to the next. The chapter 8.2. Suppose you want to estimate the population proportion P. As an example, you may be curious what proportion of students at your school smoke. Students smoke. Okay. Or you could wonder what is the proportion of accidents caused by teenager drivers who do not have a driver's education class. Confidence interval for one population proportion. One proportion interval. State the random variable in words x, that the x to be the number of successes. P, the proportion of successes. State and check the assumption of the confidence interval. A simple random sample of size n is taken. B, the condition for the binomial distribution are satisfied. Why that is binomial distribution? Because yes or no, successful or non-successful, smoking or not smoking, already taken the driver's education classes or did not take the driver's education class. Okay, yes or no? Thus, we use the binomial distribution. Okay, then to determine the sample distribution p hat, you need to show n p hat. Thus, n times p hat is greater or equal to 5, and n times q hat greater or equal to 5, where q hat is equal to 1 minus p hat. Yeah, you can check chapter 7.2. We learned the concept here. If this requirement is true, then sampling distribution p hat is well approximated by a normal curve. Okay. 3. Find the sample statistic and the confidence interval. The p hat, that is x divided by the n. X means the number of successes, and the denominator, that's the number of trials. And we can know that the confidence interval p hat minus estimator smaller than p hat plus estimator. We can observe that minus plus. Again. P is a proportion from the population. Population may be thousands of people. It's impossible to get the value, to get the proportion. Thus, we select maybe 30, 40, 100 samples to measure the value. We get a p hat here. And now we try to find the real population. The value we are locating between one range. That will be p hat minus estimator plus estimator. So far, okay? P hat and margin of error, E critical value, Q hat, and E like this one. So the E, that is Z times the square root of P hat times Q hat divided by N. Okay, we can check this question. The example 8.2.1 confidence interval for the population proportion using formula. A concern was raised in Australia that percentage of death of observing prisoners was higher than the percentage of death of non-Aboriginal prisoners. Yeah, we checked a similar question previously, which is 0.27% as an example of 6 years of data were collected, and it is found out of 14,495 Aboriginal prisoners, 51 died. Find a 95% interval for the proportion of this one. Okay, how about 2 minutes? We can finish this question. Let's check this and calculate this. Later, I will have office. We can calculate this question. 2 minutes. We can start to calculate. Okay, let's check here. Okay, the solution here, that the X is the number of aboriginal prisoners who died. The proportion P, the proportion of aboriginal prisoner who died. Okay, then a simple random sample of 14495 Aboriginal prisoners was taken. However, the sample was not a random sample since it was data from 6 years. It is the number of all prisoners in these 6 years, but the 6 years was not picked at random unless there was something special about the 6 years that were chosen, and the sample is probably a representative sample. The assumption is probably made. Okay, and there are 14,495 prisoners in this case. And the prisons are all Aboriginal, so you are not mixing Aboriginal with non-Aboriginal prisoners. And there are only two outcomes: either the prisoner die or not die. Okay, not die. The chance of the one prisoner die over another may not be constant, but if you consider all prisoners the same, then it may be close to the same probability. Thus, the assumption for the binomial distribution are satisfied. In this case, the x is 51, and the n minus x is 14,444, and both are greater or equal to 5. When we time that together, the number is very big and fit the criteria. The sampling distribution of p hat is a normal distribution, no problem. Okay, then the sample proportion p hat is x over n. 51, the death cases, 51 over the total number is close to 0.003518, and the confidence interval, yeah, if you forgot the formula, we can review the formula here. The formula is p hat minus e, p hat plus e, but the e is a little bit of trouble to calculate. E is the critical value zc times the square root of p hat q hat over n. Okay, the critical value ZC 1.96 because the 1.96 is the 95 the confidence interval. Okay, who can tell me? 1 minute, please. Who can tell me what is 95% interval at 1.96? What does it mean here? What's the number 1.96? And what relationship between 1.96 and 95%? The first three with the correct answer, I will give the bonus mark. 1 mark in the end in the grade. Is that okay? 2 minutes. Is that okay? Let me say the question again. The critical value 1.96, where does it come from? What's the relationship from this one to 95%? Next time I should have I have the money and give you the but now I have no money. So if you can answer this one correctly, I will give the bonus score in the final grade. 1 point, 1 mark. Okay? 1 minute and 30 seconds. Get it? Why 190? So 1.96. So ugly. You can 1, 1.5, 2, 2.5, 3, 3.5. Why 1.96? What's the relationship between 95%? The table, oh, I'm not satisfied with this answer. We're going to challenge this.
1.96 can standard normal distribution.
I'm not satisfied with this question, with this answer. We accept this value, but what does it mean? Sure, I have my own ideal answer here. I want to.
Mean is 0 and standard deviation 1.
And 1? Can you say that again?
Mean is 0.
0, then standard deviation
is 1.
Not my answer. Why 1.96? Why and what's the relationship between this one and 95? Let's minutes. If no one can answer this, I think I can. Can you say it again?
Probability tables of the standard normal.
I know what you're talking about, but you cannot persuade me that you understand the question here. Sorry. 30 seconds. Ajahn? Comments? Oh, no problem. Hold on. 20 seconds.
This is for 0 and plate
Z table and what's can you
because in standard normal distribution, negative 1.9 related to C, and then 1.9 positive 1.9. So the area between negative 1.96 and positive 1.9 is approximately 0.
Very close. Can you say that again? Very close. Can you say that again? You have one more chance. Well, I know you. Can you clearly? So it's not about the language or English. Can you say that again?
In a standard normal distribution, the area between negative 1.96 and positive 1.96 is approximately 0.95. So it equals 0.95 is equal to 95%. So that means 95% of the values are inside the interval and 5% are outside the interval.
Okay, you got a score. Right, sure. And then in our language, we said, 重赏之下必有勇夫. It means if we have, we offer great opportunity or some 重赏之下 okay. some prize, and there will be someone stand out to earn the prize. Okay. So sorry, my translation is not good. Okay, let me read. How many please? Let me. Okay, here. Okay, before I move on, I want to show you one thing. Normal distribution. We can use from Wikipedia. Okay. Okay, let's check this first. And we mentioned the samples are normal distribution. The samples, okay. Then we know that generally the distribution like this one. Then here is the mean, and here is the mean plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations. But generally, when we plus 1 standard deviation and 2 standard deviation and minus 1, plus 1, minus 1, and the value between this one will cover 68.2 of the total population. Get it? And if we use the value the mean plus 2 standard deviations and minus 2 standard deviations, and the range here will cover about 96 of the total population. For example, the height average maybe 170 degrees Celsius. So centimeters. So 170 centimeters. Sorry. Okay. And minus plus this range will cover 96 population. But now we don't like 96. We use 95. After the calculation, 95, that is the B plus 1.96, not the 2 standard deviations, plus 1.96. Is okay? That will be on a little bit close to the line, but on the left side of here. And mine here, close to here. Thus, this distance is 1 standard deviation, 2 standard deviations, but that is 1.96 over here. And the range here will cover 95% of the total population. Get it? I know you're hungry and you want your dinner now. Okay. Please write down your name again, actually, and your student number in our online group, I will answer, okay, you get 1 mark in the final score, in the final grade, okay? Oh, you already did it? Very good. Okay, let's move back here. Then, so 1.96, actually, it covers not 96 or 96.5. It covers only 95%. 95% is close to the right side here, and plus 2 standard deviation, but not 2, is 1.96. A little bit close to the left. And this range will cover 95% of the population. Get it? But why 95? I don't know. Because I just guess maybe the scientists, they think 95 is a reasonable value. Okay, let's move here. Thus here, using 1.96, and it will cover 95% of the population. And we can think that there's 95% interval. And here, Z, the critical value, ZC, 1.96 times the square root, the p-value, the p-hat, 0.003518 is here. And times the q-hat. Q-hat is 1 minus q. 1 minus p-hat. 1 minus 0.00313518. And the value will like this. And excuse me, can you calculate this one by the calculator? Can you calculate this one? Let me show you. 1.96 times. Sure, next week I will tell you how to find the confidence interval calculator. By this time, I hope you can calculate it by typing the calculator, okay? Times square root 0.003518 times 1 minus 0.00318, then divided by 14,495. I know it's really ugly, but and click enter. Why? Why is 0? Okay, let me do it again. See, because the decimals is not available for so many decimals, but I use the Google calculator. The answer look like this one. See, my calculation from the Google calculator is very similar. 0.00096, 0.00964. Very similar, right? Okay, and next, from the formula, P hat minus E, P hat plus E, P hat minus E, and P hat plus E. Is it okay? Then we get the answer here. Then, okay, close to the end, we can say that there is a 95% chance that the population proportion is in the range 0.00255 0.554 and 0.004482 with a confidence interval that the proportion can be here, and the proportion of original prisoners who died is between this one. Is it okay? Okay, I think I can stop the lecture here, and if you have a question, please let me know.